Hello everybody. Welcome to today's industry technical presentation, Expand Beyond UI with AI-powered codeless API testing. I hope everybody's enjoying STARWEST, STARWEST Virtual 2020. I know I am. My name is Chris Colosimo. I'm the product manager at Parasoft, and I'm going to be the presenter for today's presentation. Today we're going to talk about how to increase maintainability and stability of UI testing, and then how to expand beyond that into codeless API testing, and then show how you can use simulation to support virtual test environments for your API testing. So without any further ado, let's go ahead and get started. So to start with, let's talk about the disruption. Especially in this time that we're in right now, disruption is a key for innovation. We're seeing a lot of organizations that are pushing energy into their online experiences to make sure that they can deliver that seamless experience to those end customers. And I mean, think about other things, like when was the last time you rode in a taxi? Disruption is everywhere, it's constant, and it is a major catalyst for us to be innovative. And the more innovative we are, the more we beat our competition, right? You're seeing this manifest in different ways, right? Digital transformation, people are saying, well, let's bring in Agile to make things go faster, even though we know it doesn't actually make things go faster. Let's bring in DevOps so we can create infrastructure and code and automatically deliver software to the market, right? And we have to do this because switching costs have never been lower. Even people that are non-technical, I was just talking with a friend of mine who was switching away from Gmail because they saw a feature in another email client. Super non-technical person, but there's no switching costs now. We can rapidly go from software to software. And so how do we make sure that we can validate that customer experience and make sure that we're retaining our customers? And it's testing, right? We want to test what works and then make sure that it still works. And so test automation and DevOps is a lot like building infrastructure. You can think of it like a railroad. However, what's coming down that railroad isn't an old-timey choo-choo train. It's a bullet train. And if we don't ensure that we have the proper quality metrics in place for delivering our software, we can get derailed. And you see that train next to that train, the other one, that's our competition speeding right on by, right? And so we want to make sure that we're testing. And the best way to do that is to have a strategy. And here at Parasoft, we believe in building a scalable test automation strategy that aligns with the testing pyramid. And in the testing pyramid, you want to establish a broad coverage or a high amount of those granular test types like API testing and unit tests, which are easier to scale, easier to automate, while minimizing complex and time-consuming late cycle end-to-end testing that's either manual or automated UI. However, when we talk to organizations, what we typically see is the opposite of this, the snow cone, where organizations are focusing on the UI, manual testing, and they're automating what's manual. And we understand, right? It's easier to define those UI tests. They're more difficult to automate, though. And then in the lower levels of the testing pyramid, it's easy to automate API and unit testing, but it requires technical expertise. As we dig a little further in, we do see that organizations are actually starting to pick up on this and try to be better, and they're migrating into more of a martini glass, which is, we're still doing our manual and automated UI testing. We're starting to look at unit testing as an early stage testing practice, but we're skipping right past API testing. And so organizations are still struggling to adopt those lower levels of automated testing. So this is where AI can help us out. But in order to start digging into that, we have to start understanding some of the challenges. And so we run polls all the time at Parasoft. One of the questions that we ask of everybody is, when it comes to UI testing, how are you testing your UI? What software are you using? And unsurprisingly, the vast majority of people are using Selenium. It is the de facto standard when it comes to validating the UI. But when we ask people, how's that going? They say, we love Selenium, but there's challenges. Well, what are those challenges? It looks like it's all about making tests that can continue to execute even though your application is changing. right? And so it's all about maintaining those test cases. We then see, as we start going down a little bit, access to OS and browsers, identifying which tests to execute. And we have solutions for that. But what I really want to talk about today is the execution and maintenance challenges. So these are our challenges. This is what it really breaks down to. Maintaining test automation on the UI due to wait conditions. Maintaining due to locator changes. Maintaining those tests when the UI changes. Debugging and diagnosing failures when they occur, and then reducing the overall time for the test suite to execute. And at the bottom, we see the knowledge and skills to create the scripts. We're seeing people are becoming more technical. It's not as much of a challenge to create those scripts, but really, depending upon who we talk to, these challenges can change positions. All right, well, let's jump into our first demonstration, which is how we can streamline UI testing to improve automated test execution and maintenance. And so for that, I'm going to be doing a demo today where I'm going to test some custom implementations that have been done inside of my Salesforce. Specifically, I'm going to be working with the contacts flow. I want to create some UI tests, some API tests, and then I want to be able to expand that coverage on the API tests to cover all the different permutations. I don't have any tests right now, so I'm going to be using Parasoft to start from scratch, and I'm going to start right here inside of the browser. We can create tests through recording the interfaces for both UI through Parasoft Selenic and through the APIs using Parasoft SOAtest. The Parasoft ecosystem, or the Parasoft recorder, understands Salesforce. It understands how element locators should be best constructed. It understands how to dynamically construct wait conditions. And it also understands the dynamic nature of Salesforce front-end APIs. And so what I'm going to do now is I'm just going to start a recording, and I'm going to do both of those things at once. I'm going to get those UI actions that I will create UI tests from, and those API actions. So let me go ahead and log into my Salesforce system. Go ahead and put my username here, password, log in. Okay, so like I said, today I'm going to be working on an invoice flow. Specifically, I'm going to be working through some contacts. So what I want to do right now is I want to create a contact. So you see that I have two contacts here, Lisa Simpson and Bart Simpson. So naturally, I'm going to create a new contact for, let's say, Homer Simpson. So we'll give Homer a first name here, last name. Homer needs an email. Seems like kind of email Homer would have. And then there's one more required field, which is my lead source. So we'll go ahead and say discover.org. Okay. Now I'm going to go ahead and click this save button. That will then create the contact. Okay, great. Now what I want to do is I want to clean up after myself. So let's go ahead and delete that contact. Okay. So that is my use case. So what I'm going to do is I'm going to go ahead and stop my recording, and I'm going to go through two distinct workflows. The first workflow is to create the UI test. Now, I know what you're thinking. Oh, okay, we're going to see another platform where we're going to create, these UI tests inside of a proprietary ecosystem. Incorrect. We're actually going to create these tests in pure Selenium. We have the option of creating them in JUnit or TestNG. But for the Parasoft solution, the best way to move fast is to use the most common UI testing solution. In this case, as I said, Selenium. So let's go ahead and name this. I'll call this Salesforce Contacts. I could give it a description. More importantly, though, I can give it a requirement. So I'm going to go ahead and hook it up with something in a Jira that I have. I'm going to go ahead and download that recording. Okay. We'll call this Salesforce Contacts, and we'll save it. We're going to work with that in just a second. Now, remember what I said. At the same time, we're also recording the API traffic that takes place in the system. And so I'm going to go ahead and say create test asset. This is going to think for a second and use AI to construct an API test scenario. but we'll deal with that in just a second. Let's go ahead and just close that out. All right, so I have my UI tests, I have my API tests. Let's go ahead and look at those tests. So I'm gonna open Eclipse. Parasoft Selenic is a plugin for Eclipse and IntelliJ that allows you to work in your most familiar IDEs and create these pure Java Selenium tests. If I wanted to, I could actually merge a test right here into an existing project, but I want to start totally from scratch. So I'm going to create a Selenium Java project from scratch. I'll call this Salesforce contacts. Do a little underscore here, contacts. And I'm going to grab that UI recording that I just created. Okay, I'm going to give it a package, something like com, the name of my company, and then the piece that I'm working on, which is contacts. And then we'll give this a class, test, contacts, create. Okay, we'll hit finish. And that's all I need to do. I actually now have a Selenium Java test. Here in this case, I'm using JUnit 5, but you'll see that it's gone ahead and put together all the bits and pieces that are required to use Selenium in Salesforce and takes a lot of the post manipulation out of it. Additionally, I'm using an industry best practice known as the page object model. Now, the reason that this is an industry best practice is because it makes really highly maintainable test cases, because it creates elements and locators as reusable objects that you can define in one location. And if you ever have to change those elements, you just change it in this one spot and it propagates through the rest of the test. And again, this is partially why Selenium is so powerful in Salesforce, and by using the page object model, you're taking ultimate advantage. But I want to go fast, so let's go ahead and execute this test. So I'm going to run this with Selenic, and we're just going to play right back exactly what we recorded inside of Salesforce. Now, one of the other things that's quite powerful about this is the way that we construct a lot of these original locators and weight conditions. You see, we understand how elements are constructed inside of Salesforce, usually using something dynamic like an ID that changes all the time. And so we try to create the best element locators possible by looking at other things that Salesforce provides, like class names, even using really intelligent strategies to pivot from a label to a field. Okay, well, that's great. I just ran my test. It passed the first time, which is pretty spectacular. What I want to do now, though, is I want to talk about change, and I want to talk about maintenance. So as I expressed earlier, we have the page object model, which helps us update our tests if they were to change. And that simplifies the change process. But how do we know what's changed and how to quickly update that test? And that's where Selenic's AI becomes quite powerful. So when I just ran that test, what I did was I was actually watching and I was capturing all of the information in the browser about the elements that I was clicking on, the different pages, and I was using that inside of Parasoft Selenic to understand how successful each one of the tests was on clicking elements, navigating the pages. The reason that I do this is because as applications change, Selenium tests break. And this is why we see a lot of people resistant to using Selenium in something like a Salesforce. Parasoft Selenic can generate recommendations for field locators and weight conditions, and even things like stale element references or changing IDs, and give you new locators and even self-heal the tests at runtime. So I'd like to give you an example of that. So I'm going to turn on a couple of options. First, I'm going to perform self-healing. And then I'm going to say, go ahead and give me a report and tell me what happens when the test fails. And additionally, I'd like to understand some performance metrics about my application. I want to know if any of my tests take longer than they usually do to execute. So I'm going to go ahead and apply that, and now I want to break my test. So in my application, when I created that Homer entry, I clicked the Save button. But let's say that didn't always say save. Let's say in a previous version, that said continue. Okay? This kind of thing can happen. We just change a button, we change a label, we change where a tab is. It's a small change, but it could really break the Selenium test. And so what I'm going to do now is I'm going to execute this, and we're going to see Selenic's self-healing not only fix the change, but also provide us back a recommendation on how to update the locator. So I'm actually move the Salesforce UI here to the left. Okay, so we're going to go ahead and log in. We'll wait for this page here to load. Okay, we'll go ahead and create a new contact. Okay, now keep your eyes on the console on the right-hand side. It's trying to click save. It can't. It's thinking. It says, you know what? I'm going to try some different locators. It found one. It clicked the save button. My test proceeds. My test did not fail and was automatically healed from a breaking change because of the AI in Parasoft Selenic. See, it makes Selenic easy, or excuse me, it makes Selenium easier to use. All right, so let's go ahead and look at this report. So this is our Parasoft Selenic report, and what it's saying is, yeah, you had a test that you executed. It didn't pass, but it was automatically self-healed. And it says here, I was not able to click on this continue button, and also provides us with a screenshot to say, this is where my problem was. Okay. But because of the AI, the test did proceed forward. Why so? Because when it encountered that continue button and went back and took a look at the different ways that the page was constructed and said, you know what, actually, if I use this element locator, save, or maybe this or this, you'll see it's providing different locators to us to make it easier to choose one that makes sense for our organization strategy. It says you'll have a 98% confidence factor that this will work in the test. And guess what? I also tried it and it was successful. It also provides us test details and a stack trace so that we can feel confident in using this in our UI test execution. Okay. Now, if I were to go back into my IDE, I would say, okay, so I know that there's something about the test that needs to be updated. And I see that those locator recommendations were provided right here back into my IDE. Now, not only can I see those element locators, but I can actually jump right to the line of code and automatically update that locator. I can hit my save button. I can go ahead and re-execute my test and feel confident that this change that was applied will fix the Selenium test execution. And this completely or significantly reduces the test maintenance associated with those UI tests. All right, so what did I just show you? I just showed you how we can reduce the maintenance costs associated with UI testing. This also gives us a jump start on API testing, but I'll talk about that in a second. I did show this in Salesforce, but this is broadly applicable to any type of application that you're trying to test. The workflow was to enable the recorder to simultaneously record UI tests and API tests. Those UI tests were then delivered back into my IDE as pure Selenium tests using the page object model. The maintenance reduction came during the execution time, where as I executed those here in the IDE, but really inside of my CI pipeline, if there were any failures due to bad weight conditions or element locators that were insufficient, the solution would retry, self-heal, and then deliver those recommendations back into the IDE for quick fix. Also, because we supplied the annotations, the requirements number, the work items, we could also synchronize those with requirement systems such as Jira, X-Ray, so that we could really get a handle on those tests. Okay, but what about API testing? So API testing is an excellent practice. We really focus on it at Parasoft. We believe that there are many benefits, such as being able to really thoroughly validate components individually or end-to-end inside of an application. You know, the UI only tells one story, these APIs tell the rest. It also serves as a really good communication channel between dev and test, because if you find a defect, you can simply provide an API test to the developer to reproduce, which is, it's much quicker to remediate because you're so close to the code, and it really forces down and shifts left the defect remediation time. But we see that folks are really hesitant to move into API testing because it has technical complexities, barriers, insufficient tools in the market, and also it requires a high level of skill to understand how these APIs work. So it really kind of turns into a no man's land, and that's where we can, you know, really turn to AI to help us out. And there's some significant benefits to the quality associated with API testing. If we look at this data here that was provided by a recent survey, we asked how much of your time is actually spent on API testing, and you can see that there's a pretty small amount of time that's actually spent on API testing. You know, 2/3 representing less than 40%. And what does that mean? Well, when compared to other testing types, such as unit testing, API testing, and automated UI testing, the amount of coverage that these same organizations said they were able to achieve with API testing and unit testing was vastly above that of just purely automated UI testing. And of course, we're touching more components, we're being able to see pieces in isolation. But what does that relate to? We're finding that organizations that focus on an API testing strategy find defects earlier. They're able to remediate them faster, which creates, you know, higher quality in the application and ultimately shorten testing cycles and improve time to market. So we'd really like to show you how that all comes together. So let me jump into the next part of my demonstration, all aimed at Codeless API testing. All right, so when we created this UI test, one thing that I pointed out was that we covered that use case, but our performance benchmark was saying, okay, average 30 seconds, this execution took 35 seconds. What I'd like to do actually is I want to keep that. I want to keep that report and put it off to the side because it's going to become important for us in just a second. Because at the same time that I created those API tests, I also created UI tests inside of our API testing solution, Parasoft SOAtest. So here I am, Parasoft SOAtest. And when I created those tests, you saw that little pop-up here in the corner. What it was actually doing was delivering that test over here to my API testing engine. And here it is, Salesforce Contacts. Let's open the box and look at the API tests. Okay, so this, what you're seeing here, is all of the APIs that were called in sequence from the browser to the front-end API. Now, it's not just a sequence of API tests. These were created with AI. And what that means is that when we created the tests, we were looking for dynamic information that was being exchanged between the different steps. Things like FUID tokens, Aura headers, session IDs, so that we could negotiate the authentication and the dynamic data and the IDs that are being populated as you're going through a sequence. And you'll notice that we've created a whole bunch of smart tools, smart header data banks, smart JSON extractors, Aura token extractors. Basically, Parasoft's doing the heavy work to make sure that your API test works the first time as expected. So let's go ahead and just collapse this guy. And I'd like to show you how this would work against the application. So what I'm going to do is I'm going to grab this UI here. I'm going to put it on one side. We'll put SOAtest on the other. And let's just go ahead and execute this sequence. We'll go ahead and, sorry, I got a bar in my way here. We'll hit play. And so what we should be seeing now is the exact same action that took place in the UI now being executed from the API perspective. You can actually see in the console all the posts, and look, Homer just showed up. Now we'll do some more posts and some more gets, and then we should delete Homer, and then there's our use case, okay? 63 APIs were just called, reproducing the exact use case that we had in the UI with the API, but look at the time. That only took us 19 seconds. Now, that compared to our original 35 seconds, that's a pretty significant reduction to perform the same use case that we're doing from a validation perspective. Now, we could take this even further. You see, when I'm actually interacting with the Salesforce application, a lot of these API calls actually have to do with asynchronous calls that are made from the front end to populate those form IDs. And they're not actually necessary to perform the action that I'm looking for, which is creating the Homer contact. So what I've done is I've actually reduced down that API sequence into just the required calls, which are these 8 calls for authentication, and then this one this one post to create the contact. Now what I'm going to do here is I'm just going to log back in to Salesforce. Dog. Look at my contacts. Okay, so now we're going to do the same thing here, and we're going to execute this sequence of events here, starting with authentication, and we're going to create a contact. So we'll see in 7, 8, 9, 10, post create, 6 seconds later, and there's our Homer J. Simpson. Now that's a significant reduction. Now I'm doing that same use case in just a fraction of the time. And what's also interesting about this use case is if we look at the data that's being provided to actually create the contact, there's a lot of fields that are available in that contact UI that we just simply didn't interact with. Let me make this a little bigger. You'll see that we have things like birthday, account site. Maybe we do things like the middle name or mailing address. And so we would want to validate all of those fields in the UI, but it might become cumbersome and could break actually quite often if we created those all as UI tests. So instead, what's a really good strategy is to create a subset of UI tests to validate the user's experience, and then cover all the rest of your permutation testing using the APIs. Let me show you an example of that. So here, instead of just creating a contact, what I'm going to do is I'm actually going to create a bunch of contacts. And I'm going to create them with different types of data. So I've just created a little data source here to say, hey, I'm going to create all these different characters. I'm going to give them a different account site. I'm also going to use data generation to automatically generate a phone number. And then I'm just going to shove that into the into my Salesforce system. So I'm going to go ahead and just shrink up some of this. We'll just assume the authentication has already taken place because we have our token. And now I'm just going to fire this test off. So here we see at the bottom, 1, 2, 3, 4, 5, 6, 7, 8. It's going to go through each one of those characters, doing a data generation, a client, and then validating that client. And so we say 18 tests that executed in 10 seconds. So let's go ahead and take a look here inside of my Salesforce and look at all that. And as you can see, from just that one simple recording, I was able to get deeper and deeper and deeper into the application, creating more and more tests to cover more aspects of Salesforce. And it just kept getting quicker and quicker and quicker. And that speed is vital to the quality practice, especially when we start thinking about, and this will be the only time I mention COVID during this presentation, when we start thinking about the digital disruption that's taking place right now and all of the different experiences that we're having to create and the different ways of delivering that, we have new methodologies, new protocols, new interfaces, maybe systems we've never integrated with before. And so being able to rapidly validate each one of those pieces, in its entirety becomes really, really important. And so that kind of leads into the next piece here, which is the increasing complexity of testing requirements. So, we have strategies here for testing across our applications, especially when we think about the different layers that they have, the front end omni-channels, the middleware systems that represent all the APIs and databases we need to connect with, in the back end systems that can be really challenging for us to test, especially in an accelerated environment. Now we have solutions for testing these individual components in isolation, but I hope that I've shown today that through Parasoft SOAtest and Parasoft Selenic, we can really rapidly build tests against these different interfaces, be they web, mobile, maybe a direct API call, even databases, which we didn't really get into today. But in our tool suite, our Codeless tool suite, databases are treated exactly the same as any other API. And you know what? The same applies for IoT and microservice protocols. But again, conversation for a later time. All these kind of tests you can reuse for performance and security tests because you already have all those attack vectors. But one of the things that becomes really challenging in an ecosystem like this is as soon as you create this great automation on the front end, the problem really shifts to the back end, where you have back end systems that are maybe pay-to-play APIs that you're integrating with. Maybe you're dealing with a sandbox that doesn't have the behavior that you want. Maybe you have APIs that are changing and the ones that you want aren't exactly ready yet. Or maybe you're trying to do performance testing in an environment and you require the entire environment, and that's very expensive. All of these things can be solved through simulation. Parasoft Virtualize is our simulation technology, very similar to SOAtest. Codeless supports 150 plus message formats and protocols. It makes it easy to create simulated representations of these back-end systems so that you can stabilize your application under test, be it on-premise or in the cloud, and do things that you wouldn't traditionally be able to do in your real test environments, like negative or defect virtualization. This plays into a DevOps ecosystem because if you combine these two with your safe test data or generate the synthetic data that's required, you can actually containerize this entire test environment. Parasoft takes an environment-based approach to testing, which says take all those test cases, virtual services, load them up into a predefined template, deliver it to an individual tester or developer to work right there on their desktop, or as a part of your CI pipeline, whenever code gets checked in, after you run your static analysis and your unit tests, you can then deploy versions of your test environment for functional testing. You can do this either by using VMs or taking advantage of things like Docker and Kubernetes in cloud platforms like Azure DevOps and Amazon EC2. And really what that allows you to do is to create more swim lanes, more test automation that can execute and give you a greater quality through increased coverage. So what I'd like to do now is dive into a demonstration of how that would work here in my application. Inside of this application, when I'm actually creating a contact, I'm not just creating a contact for fun. I'm creating the contact because it's a part of a larger process. So what I'm going to do is I'm actually going to go into the Parasoft continuous testing platform. Go ahead and log in here. The Parasoft continuous testing platform is an on-premise or cloud-based dashboard that allows me to see the different environments, execution flows inside of my different applications, create API tests, virtual services, generate test data, and associate them with my use cases, with my workflows. I can then use those to run an automation, dynamically deploy containerized environments, etc. So what I'm actually doing when I'm creating that account is I'm eliciting an entire invoice flow that goes from creating the invoice, creating the account, performing the credit check, and etc. What I'm doing when I'm creating that account, though, is I have connected to this Simpsons API that has this database of characters and different episodes that those characters are in. And what I am doing is I've integrated that API into my Salesforce flow. So those who were keen-eyed would have noticed that when I created a character, or when I created a contact, here under details, I have this integrated API where I could actually call out and get various episodes that character was associated with in the different seasons. Okay, I'm just having fun here, showing the power of Salesforce and their integrations. So here I see that in the fourth season, there's a whole bunch of episodes, some descriptions, Disney Plus ID and Simpson World ID, which is important for the invoicing for this to make sure that this data gets pushed all the way through the pipeline. Now, what's really interesting about this is that this API is actually pay to play. Every time I call it, it costs me money, which should be very familiar to anybody using pay to play APIs that are integrated into Salesforce. But what's actually happening here is I have simulated this API. And I did that through recording, very similar to what you saw when I was creating the API test. So I'm going to go ahead and just turn that on. And let's go ahead and look at that service. So here's the service over here. It's called the Simpsons Virtual Service. And basically, I just have a whole bunch of different episodes that I had recorded and created a data model for the different types of information that's in an episode. The advantage here, though, is that I'm completely in control of the data that is connected to my Salesforce implementation. So let's go and change some of that data. So here we are back in Salesforce. What do we look at? Season 4. So let's go find season 4 right here. And let's say that what I really wanted to do was to say, instead of Bart and Lisa being horrified when their summer camp was not as fun as they expected, let's make that actually Rod and Todd Flanders. How about Rod and Todd? Now, of course, this is just having fun with The Simpsons, but imagine if you wanted to inject customers that had all sorts of different data, maybe data that wasn't even possible in the real Salesforce system, and you wanted to see how that would interact with your UIs. By using a virtual service, I am now completely in control of that data, of that service. I can deploy it whenever I want on demand and create multiple swim lanes for my application and really unblock my DevOps pipeline by essentially being able to test constraint-free. And I think it's worth mentioning what constraint-free means. So if we travel back to the continuous testing platform, a big piece of this is the environment management component. Once you have all of this test data in these virtual services, as I was talking about earlier, you want to be able to deploy these as a unit, as a part of your build process. With a solution like this, it's as easy as defining the flow, defining the tests, defining the virtual services, and then simply copying that, either sharing or duplicating individual services to the server of your choice. Again, whether that's an on-demand server in Azure or Amazon, or maybe a Docker instance on a VM in your network, it doesn't really matter, but you can deploy that entire bundle of services and tests and the associated data, and then execute the test cases, all powered by REST APIs under the hood, and it really unlocks the capabilities of your DevOps pipeline. So that was the last piece. Remove constraints in your DevOps pipeline with synthetic data and dynamic test environments. Now, again, I've been showing you a lot of this in Salesforce, but this is a proven technique to expand coverage, test coverage in any application type. And AI is a big component of this. And what are we aiming at with all of this? We're aiming at continuous testing, right? The execution of all of the tests required to validate code changes during each stage of the SDLC. We do this as a function of code check-in, and it gives us immediate and ongoing feedback. And real organizations get real results with this beyond just being able to, to have a tick box that says I have this level of coverage. Some of our organizations achieve the greater test coverage, identifying APIs that are documented and undocumented. But really, and this is close to my heart, being a tester, this reduces tester fatigue. As we make big changes to our application and introduce new APIs, testers have to cover them. They have to create tests for them. And sometimes that's a big mountain to climb, especially when we introduce a whole bunch of services and integration with third-party services. Finding them, testing them can be really, really complicated. This helps organizations streamline migration to the cloud by creating services before they're ready or before they exist, shoring up environments in the cloud with simulated services, grabbing those API tests, getting that coverage. And really, it's all aimed at reducing test costs. Now, shameless plug here. Let's talk about Parasoft's continuous quality suite. We've only seen a couple of the solutions that Parasoft provides. Again, we align to the test pyramid, and that really starts all the way below what you would expect with static code analysis. Identify issues in your code as you're writing the code. And then with our JTest solution, we can automatically build unit tests inside of your Java code. As we work up the pyramid, this is what we were looking at today, which was our SOAtest API testing solution in combination with the Smart API test generator to really take a bite out of the complexity of that API testing. All of this can be reused for load and performance testing, so you can shift left that performance testing solution. You can then stabilize those test environments to do this type of testing through service virtualization, which I believe is one of the most powerful enablers for a DevOps process. And then, of course, at the very, very top, Parasoft Selenic, which reduces the maintainability challenges associated with Selenium UI tests. So I hope you found that valuable. There's a whole lot more that we can share with you about testing and testing in general. So visit us at the Parasoft virtual booth. Strike up a conversation with us. I'll head over there right after this presentation. But if you want to, here are some more resources. A link to our blog focused on the AI and machine learning page, the actual Parasoft product page, and then our YouTube page, because I think videos are better than reading blogs. Just my personal opinion. So with that, I'm going to go ahead and take a look to see if we have any questions.